Hey everyone, welcome back to another math video. In today's video, we're going to be talking about how the angles are related to the sides in a triangle, and we're also going to be talking about the triangle inequality theorem. Let's go ahead and let's get started. So here I have a triangle with all of the angle measurements labeled for us. Okay, and the way that the angle is related to one of the side lengths is that the bigger the angle, the bigger the side opposite to that angle is going to be. So, for example, 30, this angle of 30 degrees, on the opposite side of it, we have this shorter side length with, actually, let's give these labels, A, B, and C. Okay, so side A is opposite to the angle of 30 degrees. Now, the way the angles work is that the bigger the angle, the bigger the side is going to be, or the smaller the angle, the smaller the side is going to be. So if I was to order these from biggest to smallest side, even though I don't know them, I can name them in order based off of the angle measurements. So I would start off, let's say I'm going from smallest to largest side length. On the smallest, okay, I would be A, because 30 degrees is my smallest angle. Then 70 degrees and 80 degrees. 70 is smaller than 80, so whatever side is opposite to the 70 degree angle would be B. Finally, 80 degrees is my longest angle, so since side C is opposite to that angle, that means that side C is going to be my longest side. Okay? And the opposite is also true. Okay, if they didn't give me the angles, let's say I didn't have these angles, whoops, erased a little too much there. Let's say I didn't have these angle measurements. Okay, I'll just draw a new triangle. Let's say I didn't have these angle measurements, and all I really had was the side lengths. Okay, let's say this is 14, this is 8, and this is 10. I can tell you which angles are going to be the biggest or the smallest, or I can name them in order based off of these side measurements. Let's say this is A, B, C. So again, let's say I'm going from smallest to biggest. I would look at the smallest side, which is 8. Whichever angle is opposite to this side, which in this case is A, that is going to be my smallest angle. So A is my smallest angle, which it does look that way. Then I would look at, okay, what's my next smallest side? Well, that would be 10, because 10 is smaller than 14. So opposite to side 10 is angle C. So then it would be C. C is my next biggest angle. And then the biggest side will be opposite to the biggest angle. So 14 is opposite to angle B, which means angle B would be the largest angle of these angles. And that's how these angles are related to their sides. So let's go ahead and let's look at a problem where we have to use this concept to find missing side lengths or angles, or maybe to even put them in the correct order. So here I have a triangle where they've given me two of the angles. They told me that one angle is 65 and the other angle is 58 degrees. It says identify the sides of triangle NOP. Which is the longest, which is the shortest? Okay, so in order to do this, the first thing I actually have to do, I have to find what this missing side length angle is. Since I have two of them, I'm actually able to do this because, let's say we're going to call this angle X for now. Okay, or we know it's angle O. We'll just name it angle O. I know that if I add these together, 65 plus 58 plus angle O, I should get 180 degrees, because all the angles inside a triangle need to add up to 180 degrees. 65 plus 58, adding these two together, okay, you should get 113 plus angle O equals 180. Okay? Actually, that should be 123, if I'm not wrong. Then the next thing I would do is I would subtract 123 from both sides. So to 180, and I'd find out that angle O is equal to 57 degrees. So it's very close to those other measurements. 57 degrees. Okay? So now that I know that missing measurement, now I can actually tell you which sides are going to be the longest and the shortest. So the biggest angle is 65 degrees, which means side OP is the longest. Side angle 57 was the shortest, so that means that side NP is going to be the shortest. So this is a little bit about how we use angles to determine side lengths, or the opposite, how you could use side lengths to determine angle sizes. Alright? So now let's go ahead and let's move forward and let's talk about the triangle inequality theorem. The triangle inequality theorem talks about how side lengths are related to each other. So it's true that for any triangle, if you take two of the side lengths, they should add up and have a sum that's larger than that other side length that you didn't choose. I should be able to take any two sides of a triangle, add them up, and that will always be bigger than the side that I left out. Okay? So if I add A and B together, that should be greater than C. If I add A and C together, that should be greater than side B. If I add B and C together, that should be greater than side A. I need this inequality to be true. If it's not, then I'm not really working with the triangle, and I end up getting some image kind of like this, where one side won't connect to the other triangle. Okay, so this is a condition that has to be true for all triangles. Alright, so let's go ahead and look at a problem where they want us to sort of test this out to see, hey, can these be the sides to a triangle? Alright, and this is really what we test out. We test out these three things. We add all the different combinations of two sides and make sure that they're always going to be greater than the third side. So it says determine whether the side lengths could form a triangle. So here we have the numbers 13, 15, and 9. Okay, so let's go ahead and start adding them. Remember, we just choose two of them. Let's add them together and see if they're greater than the third side. So let's start off with 13 and 15. 13 plus 15, is that greater than the third side, 9? 13 plus 15 is 28. 28 is greater than 9. Check. That makes sense. Now let's see if 15 and 9 add up and are greater than 13. 15 plus 9, is that greater than 13? 15 plus 9 is 24. 24 is in fact greater than 13. That checks out. So now there's only one more I need to check, and that is what happens when I add 9 and 13. So we get 9 plus 13. Is that going to be greater than 9? I'm sorry, not 9, 15. Which is the third side. 9 plus 13 is 22. Is 22 greater than 15? It indeed is. So this does tell me that these three sides could in fact form a triangle together. If any one of these was a false statement, if any one of these equalities came out false, where it said something like 9 is greater than 28, that would tell me that this is not going to be a triangle. These pieces do not fit. That's when I would get something like one side is just short of becoming part of a full triangle. But because all of these statements were true, it means that these can definitely be the sides of a triangle and they will connect. So hopefully now you feel confident enough to be able to use the relationship between an angle and the sides of a triangle to determine which are going to be the longest or shortest sides, or which are going to be the biggest or the smallest angles. And also you feel confident enough to use the triangle inequality theorem, okay, which kind of gives us a clue of, if I have these three sides, could I actually form a triangle with these three sides? we now have a way to test that. As always, feel free to rewind, rewatch, relook at any parts of these videos. Definitely go at your own pace, that's always best. I just want to thank you for watching, and I hope I see you next time.